spatially independent of the distance from the antenna. If the antenna has a maximum overall dimension d, the far field region commonly taken to exist at a distance greater than r2, that is 2d square by lambda, lambda being the wavelength and the far field patterns of a certain antenna such as multi-beam reflector antenna, the sensitive to variations in phase over their apertures. So this is the far field. You can see in the diagram. There is reactive near field. This is radiative near field, and this is the far field of the antenna. So actual radiation is always takes place in the far field region of the antenna. The same what we have explained earlier is shown in the slide. Now let us focus on the other important fundamental parameters of the antenna, that is radiation pattern, directivity, radiation resistance and efficiency, power gain, bandwidth, reciprocity, receiving antenna aperture, beam width and directivity, the fringe formula, that is antennas in free space, and the polarization matching. So let us move towards the radiation pattern. In antenna, a radiation pattern or the antenna pattern is defined as a mathematical function or graphical representation of the radiation properties of the antenna as a function of space coordinates. In most cases, the radiation pattern is determined in the far field region and is represented as a function of directional coordinates. So radiation properties includes power flux density, radiation intensity, field strength, directivity, phase or polarization. The radiation property of most concern is a two or three dimensional spatial distribution of radiant energy as a function of the observer's position along a path or surface of constant radius as shown in figure. This is one of the example where the horn antenna is radiating in a specific direction. So this is the major lobe of the radiation pattern and these are the side lobes. So in a 2D radiation pattern, for example, which is a elevation plane pattern or azimuth plane pattern, the elevation plane pattern is nothing but the towards the vertical direction, and azimuth plane pattern is nothing but the towards the horizontal direction. A trace of the received electric magnetic field on a constant radius is called the amplitude field patterns. Amplitude field patterns. On the other hand, a graph of the spatial variations of the power density along a constant radius is called the amplitude power patterns. The field and power patterns are normally with respect to their maximum value, that is called the normalized field and power patterns. Also, the power pattern is usually plotted on a logarithmic scale or more commonly in decibel. The scale is usually desirable because a logarithmic scale can accentuate in more details those part of this. So this is, we can say, a 3D radiation pattern, and this is what a 2D radiation pattern where it shows the major lobe, the minor lobes, the radiation intensity in a specific direction towards the major lobe, and there are certain back lobes also has been measured. So in direction towards the maximum radiation intensity, there is a major lobe from that we can calculate the half power beam width, the first null beam width also. Actually, the field patterns, the field patterns at 0.707 value of its maximum, value of its maximum as shown in figure. The power pattern on a linear scale at its 0.5 value of of its maximum, the power pattern is minus 3 dB where of its maximum as shown in figure. So all three patterns yield the same angular separations between the two half power points. So normally in practice, the three-dimensional pattern is measured and recorded in a series of two-dimensional patterns. However, the most practical applications, a few plots of the pattern as a function of theta for some particular values of phi, plus a few plots as a function of phi for some particular values of theta, give most of the useful and needed information. So these patterns also have some radiation pattern lobes, that is major lobes, minor lobes, side lobes and the back lobes. The major lobe or the radiation lobe is a portion of the radiation pattern bounded by a region of relatively weak radiation intensity. So you can see here the major lobe, minor lobe, back lobe. Now this is sometimes the isentropic radiator is defined as a hypothetical lossless antenna having equal radiations in all the directions. It is ideal and not physically realizable. It is often taken as a reference for expressing the directive properties of actual antennas. The directional antenna is one having the property of radiating or receiving electromagnetic waves more effectively in some directions than in others. So you can see here